All right, so Jordan will take most of today to talk about Float 16, but since we've got a couple of releases coming up, thought I'd just take a few minutes to talk about it. So unfortunately, I have not regenerated this thing. I'll chop off 2022 here and add 2024 in. The next release is scheduled for the end of March. I'm gonna try to hold these. If something's really compelling, maybe we delay it a little bit, but I really do want to keep these things pretty regular. And then we'll have a 114.5 release in, I think, September. And so this one, the most important thing, aside from some optimizations for cloud optimized HDF5, we'll have hopefully the Float 16 work that Jordan's going to talk about today in it, and then a bunch of other bug fixes and things like that. The other release that we have coming up is the venerable old HDF4 library has another release that's coming up at the end of February. We are calling this one 4.3.0, even though up here I think it still says 4. Oh no, they did change it. Great. Okay, so it was called 4.2.17 for a long time. So in this one, the important stuff for the people who still care about HDF4 is that we are removing XDR. I mean, it's technically still there, but it's hidden inside the library, and the functions have been renamed so they don't symbol clash. But this is no longer something people have to bother themselves linking to because it's not in libc anymore. And the other thing is, historically, we have deployed every single header file in the repository, which is a bad idea because you cannot refactor anything if you do that. So we are only going to deploy the header files that are for the public API. So if anybody's using the internal functions of the library, you're going to be stuck on 4.2.16 on this branch for forever. So anyway, and then in the future, so we do these releases once a year. So maybe next year in 2025, we will have a 4.4.0 release where I'll have to bump what we consider our major version, which is the second one. I would like to try to figure out how to get Fortran 90 support into HDF4. And one of the problems we have is HDF4 is really two libraries in the auto tools. And so it's differently named between CMake and the auto tools. So what I want to do is just smash all that into one library called libhdf4, and then that would be the same on both platforms. And so that's something I'm hoping will come. And so that's the first announcement for people who care about HDF4. They're going to have to link to it in the future. And then with that, I think my announcements are done, and Jordan can take it away. Stop sharing my screen here, and it's all you.
Okay, let me go ahead and
while Jordan's doing that, does anybody have any questions about the releases coming up? Okay.
All right, so yeah, I just want to talk a little bit today about some new data types that we're looking at trying to add to HDF5. And these are things that people have asked for a long time now. There's been a lot of discussion around the forums and GitHub and other places about this. So I figured I'd go ahead and start with just writing an RFC to cover some of the high-level points about it, and then send it out to people and have people discuss so I can start working on this, but also get feedback from people. So the two main types we're looking at adding is 16-bit floating point types and then complex numbers. But there's a couple of other types in here that I talk about that we think are also going to be probably pretty useful in the future. So I figured I'd go ahead and cover those while I was writing this. So the motivation for this is generally around standardization, but there's also there's performance considerations and some other things to talk about when we're talking about adding these new data types. So for 16-bit floats, the main reason we want to add these is so that you can actually do arithmetic in half precision floating point types instead of them getting promoted to floats. And you can easily store the data in actual half precision float instead of having to store it as 32-bit floats and annoyances like that. And also just having standard and convenient ways of working with those types. Complex numbers is something that people have been asking for I think, probably over 15 years now. And the main reason that we want to add an official complex type to the library is mostly for standardization. Since we haven't had first-class support for complex numbers, people have kind of come up with their own conventions around compound data types. Some people have used array data types, and some people have even created data sets that have a third or fourth dimension in them to kind of store the imaginary part of complex numbers. And so it basically ends up with HDF5 files that aren't really portable across different scientific domains. And we kind of want to work towards making that better for people in the future. So here I talk a little bit about the new types we're trying to add. There's this underscore float 16, which is the recommended C standard type for half precision floating points. There's BF16, which is this brain floating point format that Google invented for mostly for machine learning stuff. We talked a little bit internally about having support for an actual native Boolean type as opposed to storing Booleans in HDF5 in something like an integer. And then, of course, the different C99 complex number types for float double and long double. So for float 16, I just talk about here about the ISO standard and talk about the format a little bit. There's 1 bit for the sign, 5 bits for the exponent, and 10 for the fraction. The BF16 type is pretty similar, except it has 8 bits for the exponent and 7 for the fraction. And I left some links here so people can go and research on those types. Boolean, I just briefly mentioned how we just want to support the actual C99 type officially. So you could basically store a Boolean as 1 bit in the file. And then I mentioned the complex types here, but there's an older RFC here that I linked to that we had created previously that talked a lot more in depth about these complex types. So I didn't really want to repeat myself here, but just bring up that we're considering adding these. And then as an honorable mention, I also say that we may, support something like 8-bit floating point types in the future if people actually use those. Somebody mentioned to me that some machine learning workflows are kind of looking towards supporting these. So something we're not looking at now, but might in the future. In the approach section here, I talk a bit about how these are actually going to be added to the library. So for example, for the float 16 type, there'd be a new macro for the native float 16 type, which somebody could use if their platform actually supports the float 16 type. Unfortunately, it's not really well supported across different platforms, mostly with Microsoft being problematic here. But if somebody has support for it, they can use this native float 16 to write out a buffer of that type. And then, of course, in the library, we want to create these standard IEEE types for Little Endian float 16 and Big Endian float 16. And these types would be geared more towards the actual on-disk format the data is going to be stored in the data set. Similarly, for the brain floating point type, there's a native macro and standard types for it. For complex types, for each of the like floating point type, you could create a complex number with. There'd be a matching native macro here, and then standard types for it for Little Endian and Big Endian. So you can see float here and double and so on. And then I didn't mention Boolean here really just because there's already standard C types for it, but we'd basically have an actual native Boolean and standard Boolean. And I had a brief section here that I'm kind of working on expanding on another version of the RFC, but talking about the on-disk format for the new data types, it's pretty straightforward. I just say a float 16 will be stored as 16-bit values on disk like other floating point types. Boolean would be a 1-bit value, and then complex numbers are there's still some debate going on around these, but they would basically just be like two 32-bit floats or two 64-bit floats or two 128-bit floats right next to each other on the disk. So that'd be pretty straightforward, and it's useful because that's how these are represented in memory. So there's a good chance you can get away with translating directly between in-memory form and on disk without having to do any data type conversions. The next section, I just basically mentioned that there's going to be data type conversions added for all the different new types we add to the library. I don't really talk about them much because they're relatively straightforward, but I have a couple other things I'm working on in this section for next version of the RFC. And then the rest of this is mostly just supporting stuff, just saying, we're going to add tests for these new types. We're going to add support to the tools. There's a brief little mention here of what complex types might look like. For example, when you're printing them from H5 dump, but that hasn't really been settled on yet. And then I talk a little bit about adding them to the wrappers and just talk about, for example, in Fortran, Fortran may support this type depending on compilers. It has native support for Boolean, native support for complex numbers. But I talk here about Fortran, Python, C++, Java, and in the RFC I linked above, there was a little discussion on the high-level library, but that should be pretty straightforward to add support for these new types to that. There's a brief mention here about printf formatting for float 16, but it's more of like a library developer type thing. And then finally, towards the bottom of the RFC here, I have a little section about portability, which just talks about things I found around various different compilers and how well they support some of these new types. Float 16 is pretty well supported everywhere except Visual Studio or Microsoft. They don't really seem to support this. The brain floating point is a little bit less well supported, except GCC and Clang, the big ones, have support. Microsoft doesn't, and then most of the odds and ends ones like NVIDIA compilers, they support it, but it's kind of hit or miss on the brain floating point, and I just wanted to put it in this RFC here because it could be useful for machine learning going forward, and so we at least want to think about it. Boolean, of course, is supported on any C99 compiler, so that should be fine everywhere. And then complex numbers are a little bit tricky because they were added to the C99 standard, but in C11, they were made an optional feature. So for the most part, everybody supports complex numbers, but Microsoft does it in a little bit of a special way. And most platforms should support this, but they have a feature test macro you can check for to see if they really do support it. So in general, it should be fine, but there may be some weird platforms that decided not to support them when they support the C11 standard. And then finally, at the last part of the RFC, I just created a couple quick examples of what using some of these new types would look like. So for using the float 16 type here, it's just creating a data set with this new standard floating point type. And then when you wanted to go and write to it, you would create a buffer here of float 16 data, create your data set generally with a standard type you'd want to use. And then when you go to write, you would use the native float 16 type here to write your data buffer. So people can look through these examples to see kind of what that would look like. So that's the RFC. If people haven't looked at it, I'd recommend going and checking it out and giving us any feedback. But there are definitely a lot of questions around mostly supporting complex numbers. 16-bit floating point numbers are pretty straightforward to support, and older versions of the library should still be able to read these types. But complex numbers, when I talk about them here in the on-disk format, the idea is that they would basically just be a new data type in themselves, so like a new class of data type. And the problem with that is that older versions of the library will not really be able to understand these data types. And so any files created with these new complex types would not be, at least any objects created with these new types would not be readable by older versions of the library. There's been a lot of discussion around this, including a forum post earlier this morning talking about trying to support these types as just compound data types, since that seems to be what mostly the community has kind of worked on. There's a couple of different representations people have come up with, even in the compound types, but for the most part, it's fairly standardized across many scientific communities in that way. But the reason for creating a new complex type is that we want to keep HDF5 files self-describing. And so if you create a new data type class of complex, somebody can read an HDF5 file and see right away that the data they're working with is complex numbers. But if your data type is just a compound, all they really see is that the data is a compound type of two floating point members, and they kind of have to understand that that data is complex numbers. So this is kind of what we're, have been discussing internally about the best way to really handle this. And I'm still leaning towards creating a new data type class, but there are strong arguments for sticking with a compound type. So I think complex numbers will probably come a bit later than some of these other data types because there's still a lot of things that have to be resolved here with respect to them. There's been some other discussion on the forum post if people haven't seen it. Let me go to the forum real quick. So one of the top topics here, this RFC post, there was some discussion initially about the backward compatibility and stuff, and being able to support the current compound approach that people have gone with in the community. So at least if we go with a new data type class, the idea is we'll be creating a bunch of data type conversion routines. So people could basically seamlessly go back and forth between the compound representation and the new complex class. So that should be fine. It's just that there's this, forward compatibility issue if we do create a whole new data type. There's a little discussion on here around expanding the data transformation possibilities in HDF5 to account for complex numbers, because data transforms currently, when you specify like a formula for the data transform, you can usually only work with one variable. It's usually you just put X in your formula there. But since complex numbers have a real and imaginary part, we probably have to think about this going forward for supporting those numbers. And then there's a little bit of discussion around Boolean types, which if we store them as actual 1-bit values on the disk, will probably also not be readable by older versions of the library. And then finally, there was the forum post I was talking about earlier where there was some discussion around how complex numbers, if we don't support them as compound data types, then it seems like we're always going to be having to create new data type classes for slightly different types of data. And one of the examples mentioned here was image formats. So you'd have basically different components for the RGB values. And it'd be most natural to store them as a compound data type rather than create a new data type class. So this person made the argument, why not just do the same for complex numbers? And I think it's a good argument, but again, there's this self-describing HDF5 files issue that we have to deal with, where just storing all this data as compound data types doesn't really tell people much about the data. So I think that's the biggest part that we're trying to nail down with complex types at the moment. Beyond that, work's pretty much always already started on this. Float 16s are almost done, and then Booleans would probably come next. And like I say, complex numbers may be a little bit later because of all the discussions around them. But I think that's pretty much all I have to talk about at the moment. And then I figured I'd open the floor to see if anybody has any questions around supporting these types.
So Mark had a question in the chat. He said util functions in HL for those common conversions.
Oh, yeah, that would be useful. We're definitely thinking about the high-level library adjustments for this. Like I say, I think it should be pretty straightforward to add high-level interfaces, but if you have anything in mind, I'd definitely like to know about it while I'm working on these. Yeah, I think that'd be very useful.
Yeah, I mean, so first off, this looks cool. And I wanted to, a number of questions come to mind. So one, I'll just throw out real quick on the complex type. I saw in one of your representations in your document that you had real imaginary there. And of course, another common representation for, you see in a lot of in engineering applications is magnitude phase. And I'm curious if that, what the basis vectors are going to be for complex numbers. Are they going to be a real imaginary? Are they going to be, oh, well, here's a set of complex numbers, and oh, by the way, here's also the basis. How are you thinking of tackling that issue?
I think that's another thing that there could be a lot of debate over. And honestly, I haven't given it much thought since I don't work with complex numbers much, but yeah, at least for the initial thoughts on it, you just have basically two floating point values on disk, and I'm just going off the C99 standard representation for them. So it's just, it says it's basically an array of two floating point numbers with the real for the first part and the imaginary for the second. Beyond that, I haven't thought about much else around complex numbers.
Okay. Fair enough. The other question I had is, I mean, the natural way that I would go about this is I'd actually use HDF5's native, low-level type creation functions and create effectively. If I was using, say, the HDF5 library as it is today without native support for complex types, I'd use the type definition functionality in it to create a new type. And then imbue that type with various, properties, I guess. And my question is, what's your sense of how much of the community, when they've needed to represent complex types in the past, have actually used HDF5's native typing capability to do that versus like just adding a dimension to an array or whatever?
Actually, there was really good discussion on this here in this forum post by this person, Peter Hill. He has this little project called NC Complex, and it's extension for NetCDF that handles complex numbers. And he talks about it here. He talks about the problem about, how communities have come up with their own conventions and everything. And he talks about the actual conventions here where we have compound data type or an extra dimension or even separate variables. And he actually even did more legwork. He went around and picked up a bunch of common applications here and figured out their conventions. So you can see for the most part, people, they're using compound types. They use R and I as names for the compound members for the real and imaginary parts. Real and image is pretty common. And then one project here seemed to use the fully spelled out real and imaginary. A couple of projects here you found are using the extra dimension, and then a decent amount of ones are actually using separate variables from each other. So I think this pretty much illustrates the problem here, right? That, there's several standards among even the several different standards.
Yeah. So the one I see in the NIF program here at Livermore is they have an extra dimension. I was looking at some of their data recently, and I was trying to handle this two, dimension size 2 in one of their arrays, and that's just because we have complex data. And I was like, oh, okay, well, wish it would have been handled a little differently. So this all sounds really cool. The reason I asked the question about magnitude phase versus real imaginary is when you get into these. And the same thing comes up, by the way, with RGB, of course, as well. As that's one basis for color. The general notion is color, and there's all sorts of HSV, CIY, stuff like that. So I don't know that there are more than the polar or rectangular basis in complex numbers, but I do know that a lot of engineering applications tend to think of complex numbers as magnitude phase. When you take a Fourier transform, that's one way that people wind up representing things as magnitude and phase. That might be worth kind of asking yourselves whether or not that's an important thing. Obviously, if you want to say in the file, it's always got this basis, it's always got the rectangular basis, that may make perfect sense. But I just wanted to raise the issue.
Yeah, there was also let me see if I can find on this forum discussion too. I know this Peter Hill guy, he brought up the discussion around the GitHub issue discussing this. And I think it was, I can't find it at the moment. I may have to go over to GitHub to find it, but there was discussion about the supporting polar form data and the idea that I want to say it was Peter Hill, but somebody in that GitHub, as she talked about, was, just store the data as, the Cartesian form. And then if somebody wants to transform the data into something like a polar form, they could do it with like a data filter or possibly even a data transform. So that seems at least reasonable at first.
Sure.
I talked to Elena about this, and she was concerned about bringing up topics around polar forms again. So she said, if anything, try and do the simple thing first, and then if people really need it, we can expand.
Yeah, that makes sense. And I see there's another question in the chat on a different topic on fill value. So thanks very much. This looks interesting.
Yeah, sure. So let's see. So a question about dealing with attributes that have the same type.
Joe, is that quote from the CF convention, basically, the theory, or something like that? Because it sounds like.
Yeah, I mean, it seems like at least initially, it looks like from the convention, but basically it just seems like asking around supporting fill values of these particular types. I mean, if there's nothing beyond that to the question, I think it should be pretty straightforward. I mean, float 16s is just binary float data, which is easy to fill with. Complex numbers should be the same way. And it's talked about in the forum post here, the C standard around complex numbers says that complex numbers have the same representation and alignment as an array of two elements of just the floating point type. So, it'd be filling the data with two float values. So that should be pretty straightforward. I know there's a little discussion here about the data should have the data type of the packed data, which I don't think should apply to any of these types as far as I know, other than maybe Booleans being packed 1-bit values. Complex should already be packed along with the float 16. So yeah, I'm not sure if there's anything else on that discussion, but I'd be happy to chat about it.
Well, unless Joe wants to jump in, but I would say that's convention. I mean, created before the complex data type was obviously available. So I don't think that can be used as, as a problem now. The community that came up with this convention will figure it out, how they want to deal with it. But, complex numbers are different thing than real numbers. That's why they're different names in math. And so they'll have to be handled differently in according of their mathematical properties. So I wouldn't worry about that specific thing.
Okay.
On polar and phase, yes. In electrical engineering, for example, or radar or whatever, yes. But I think that at the end, you can always argue conversion, you compute whatever you want out of real and imaginary. It's, I'd be careful not to get drawn into, well, I like this, like that, especially like this last post on that forum. That guy now brings the image and RGB and all. Those are all convention.
Right.
I think, in my mind, that's not something that the HDF5 library should deal with. So I think that real imaginary complex, good old-fashioned way, they'll go a long way.
Okay. Yeah, so Mark, on your question about the arbitrary precision floats, as far as standardizing them, for the most part, I'm imagining standardizing is probably only going to go around like the more common like IEEE types. So like the ones that are generally 16, 32, 64, or even 8-bit floats. Mostly since in the library you can already create arbitrary precision floats with the H5T interface that has a set fields routine where you can set the position and size of like the exponent and mantissa bits and all that. So you can basically create your own float format, and I guess it becomes a matter of popular usage, right? So like, for example, the in the RFC where I talk about the brain floating point format here, I think it's mostly just used by Google in a lot of their accelerators, but it seems to be it seems to be picking up traction in machine learning. And so if we want to work in that area going forward, it seems like something that could be useful to support. It's just unfortunate mostly that it's not really well supported across a lot of platforms at the moment. But yeah, for arbitrary precision, I guess, if somebody's using a particular format a lot, then we'd definitely consider it. But otherwise, at least you can kind of do it yourself at the moment.
Yeah, no, okay, that makes sense. Yeah, that's actually what I meant was the H5T functions. I end up using H5T a lot to do different magical things with HDF5. It's pretty powerful. But so returning real quick to this real imaginary magnitude phase thing. So yes and no to that. I mean, it's kind of somewhat similar to Big Endian, Little Endian. I mean, the HDF group could have a long time ago decided that, well, we're only going to store little endian in the file, and then we'll byte swap in the cases that we need to. But we didn't. They didn't. And what we do instead is we say, well, we've got this data in the file, and by the way, it's big endian, or by the way, it's little endian. And so what you're doing is parameterizing all the ways in which that data can be stored, as opposed to saying there's a hub format and everybody stores to the hub. With these complex numbers, you are and again, I'm just throwing this out there as more food for fodder. I'm not trying to suggest that you try to implement things, but in this case, you are picking a hub format, and the hub format is real imaginary. Same thing would happen with color space stuff. So anyhow, I just thought I'd throw it out there.
Okay. Yeah, definitely something to think about. Like I say, I don't work with complex numbers often, so I'm less familiar with, phase magnitude data and polar coordinates and stuff, at least in the scientific world. So definitely, a lot of the reason for this is getting feedback from people on that and ideas around that. So,
yeah, well, don't take my comments as that's essential. I'm just throwing it out there to generalize thought and consideration before implementation, just so that you have a clear idea of where you're headed.
Mm-hmm. Okay. One other thing which I was kind of thinking about earlier this morning, based on that forum post related to complex numbers. So I believe it was Werner had talked about how it would be nice if we could store complex numbers in the compound data type format, just so that, the types are compatible with older versions of the library. And it's something we have to think about anyway for a bunch of different types, like image formats. And so one thing I considered was to support things like all these different image formats and other types that are just like vectors of different components in the future, without having to create new data type classes for every single one of them. It seems like we basically need tagged compound data types. So when you create an opaque data type in HDF5, you can set a tag on it that's just an ASCII string that you can describe the data however you want. And so it seems like we kind of need the same thing for compound data types, so that people can have the data as a compound type in the file, but associated with a string that says, okay, this data is RGB data, for example. I don't really know what that would look like at the moment, but it seems like the natural way of going forward for supporting these types of things.
Where does the set of values that represent what the tag can be come from? Is that user defined, or is the HDF group define the set of values for the tags?
As far as I understand, the API, it's just an ASCII string the user sets with an H5T function. It can be, whatever they want. And so I don't think we really mandate any standard on it. Okay. But for some of these types, we would, for example, like if we wanted to support an official RGB data type, it would probably be a compound of those fields, and then it would have a standardized type of some ASCII string representing, this is RGB data.
Yeah. Yeah, I mean, I could see that. I could see that working. Yeah, interesting idea.
Okay. Definitely have to be thinking about that, because I agree. I'd like to make these types at least usable to people, especially since people so far have gone with the compound approach. But if we don't go with a compound data type, the new complex types won't be readable by older versions of the library.
Did we lose Jordan?
I think we did.
Well, I see him there. Everybody went on mute, I think, at the same time. So Jordan, I don't know if you can hear us, but you're on mute now.
It's really weird.
It looks like Zoom kicked me off, so
okay.
Talking through an assistant. So yeah, I missed if you were saying something there, Mark.
No, it just went blank. So yeah, these are interesting issues. I recall having conversations. Oops.
Sorry about that. All right, are we a little less echoey now?
Yeah, sounds. Okay. Anyhow, I see we're up on the time, and maybe others haven't spoken, but this looks really interesting. I'll try to contribute to the forum when I can. Okay, sure. Yeah. And yeah, if anybody has any other questions, just you can ask on the forum post there, or ask in GitHub. We have a discussion started for a feature request for these. So either one's fine.
Can you give Jordan the last, what's the latest for providing comments before, something has to be done for the release?
Mm-hmm.
So what would be the sort of the latest date
The latest date for providing
for
feedback?
comments? Yeah, feedback.
Yeah. I would say if it's around complex numbers, there's plenty of time because I think those are going to be quite a bit later. Anything around like the float 16 or probably the Boolean types would be nice in like the next week or two, since I'm actively working on those at the moment. But yeah, I get a feeling complex numbers are going to take a while, so there's probably plenty of time for feedback on those. Okay, well, yeah, thanks for coming, everyone. Any feedback, like I say, on the forum or GitHub post, and hopefully these will make it in before too long.
All right, thank you, everyone. We'll have John or his proxy here next week. So we'll see you then. Thank you.